The water that fell in the highlands erodes the land surface, carrying minerals and organic matter in suspension, and when it reaches the coast, the contact with the salt of the seawater causes sedimentation of this silt rich in nutrients. It is a strange, sinister world. The silt condenses, forming a viscous mud, corrosively acid due to the lack of oxygen. Strange forms emerge from the aquatic half-light. There is little light due to the suspended particles and a growing salinity which changes with the tides. But it is here, where conditions would appear to be precisely the opposite of those needed for life, that the different types of mangrove settle and grow. To anchor themselves to this poisonous bed, the mangroves have developed special roots. A horizontal binding system which turns the mangrove swamp into an impenetrable labyrinth. These extraordinary roots manage to extract the nutrients from the surface layer of the mud, while the intricate interweaving retains the silt coming from inland, preventing it from being carried out to sea with the tide. To achieve this miracle in a fatally toxic substratum, the aerial roots of the mangroves either have spongy tissue which absorbs oxygen from the air, or they generate roots which rise up from the bottom like snorkels till they emerge above the surface of the water. The result is that any seed deposited in these noxious muds rapidly germinate, and the mangrove forest grows inexorably, progressively gaining ground on the sea. At the surface, the mangrove swamp is a jungle of survivors. Few vegetable species can cope with the restrictions of this saline substratum lacking in oxygen, but those that can rapidly proliferate and provide shelter for a complex zoological community. For the jutias, the tops of the mangroves are an inexhaustible larder. In Cuba there are 10 different species, and one of them is this, the Demarest jutia or Conga jutia, the largest of all. Generally the jutias are nocturnal, but here in the mangrove swamps of the north of the island, they spend the daylight hours hidden among the mangroves, eating leaves, bark, fruits, and even the occasional small lizard. Like all inhabitants of the mangrove forest, the jutias remain permanently on guard. No one is safe in this shadowy maze. Down in the water lurk terrible crocodiles, while among the branches and roots of the mangrove labyrinth there are boas that eat jutias. So at the slightest movement they immediately go on the alert and flee in search of refuge. The mangrove forest offers great advantages to many birds, especially those that feed on fish. In a world surrounded by water, the mangroves provide vantage points where they can nest without fearing the land predators. And all around there are fish, invertebrates and small reptiles with which to feed their chicks. So when the breeding season comes round, the mangroves are adorned with an infinite variety of nests. For the American jabitos, the mangrove boughs are impregnable fortresses in which to guard their chicks. Here there are no predators and food can always be found, so of each clutch of eggs they lay, more chicks survive than in continental colonies. In an apparent paradox, this ecosystem, which would appear at the very limit of the ecologically conceivable, is now being revealed as a rich, diverse world where animals and plants develop in their thousands, free from the usual interference from man. This is an intermediate world created by both, between the waters of the sea and those of the rivers. A hybrid world which requires major osmotic adaptations, but in compensation offers almost inexhaustible food and shelter. The mixture of fresh water laden with new nutrients and the salt water that gives rise to sedimentation favors the increase of the invertebrates and fish, and this makes the austere wetlands and coves of the mangrove forest a meeting place for thousands of aquatic birds that come here each day to partake of the feast. In the waters of the Cuban Keys and islands where the mangrove grows, over 100 different bird species can be found, the majority equipped with long legs for wading. Each species has a beak specialized in catching a certain type of prey, so competition among them is reduced to the minimum. This one, the brown pelican, the only strictly marine pelican, uses the technique of swooping down to catch fish from the air. Others are much more sophisticated and have prodigious beaks which are the result of millions of years of adaptations in order to filter the water. No other beak in the mangrove swamp can compare with that of the flamingos. Attracted by the microscopic crustaceans that proliferate in the brackish waters, thousands of them come to the mangrove swamps. Their strange beaks are equipped with sieves that filter the water and retain the tiny crustaceans, and their stilt-like legs and webbed feet mean they can walk easily across the viscous slime. Just a few decades ago, flamingos were very numerous in Cuba, but humans have destroyed the majority of their breeding colonies, and the last specimens today hide in the mangrove forests of the main island, where inaccessibility has become their greatest ally.